So good afternoon, everyone. So today we are going to talk about technology called GraphQL. Okay. All right. So good afternoon, everyone. Again, so we are going to talk about this technology called GraphQL. So first of all, I'd like to do a little bit of evaluation of the audience. So to understand how familiar people are with GraphQL. So the first, shall we put our hands up, everyone? Do a little exercise. Yeah. So everyone put your hands up. All right. So if you have heard of GraphQL, let's put your hands down. So keep the hands up if you have. If you haven't actually, if you have heard of GraphQL, you have to put your hands down. So rest. So which means nobody have heard of GraphQL. Okay. So okay. First of all, everybody put your hands up. Everyone. Okay. If you have heard of GraphQL, put your hands down. Okay. So how many of you have done the API like GraphQL? So okay, some people have tested out GraphQL. So how many of you have done the production level API with GraphQL technology? So it seems a very small crowd from our people who are present physically here. So I didn't go to the online people, so first I'm going to talk about how this technology came to be and why people have created this technology called GraphQL. So this thing was initially created at Facebook. This was back in 2011 when the mobile transition was happening. So basically, Steve Jobs and people, they came up with the smartphone concept back in 2008, and all the digital platforms wanted to migrate all their web platforms to mobile applications. So at the time, the Facebook approach in order to make their application available in mobile was to create a mobile specific website. But at the time they have using PHP, so all the rendering has happened in the server. But going forward, so one of the problems they had was at the same time different companies have been trying out creating a native application for Android and iOS. So their web platform could compete with all of these native applications. So actually, those their own platform has been written in HTML5 and so they wanted to migrate into this app ecosystem, right? So their backend infrastructure was not fully API optimized, so they were rendering HTML and sending that kind of output to the front. So one of the problems, few of the problems they identified at Facebook were lack of hierarchical nature and select only version. So that's what I'm trying to emphasize there is basically they had some REST APIs where they were not able to show nested structure, which is in detail. Lack of features to display list of heterogeneity. So as you can see in the image in the example, in the Facebook feed, we can see multiple different types of breakout. For an example, we have posts, we could have images, we could have comments, and that is the term of heterogeneous data, which means different types of breakout available in the interface. And multiple round trips event. So all of these points we will cover in detail. So they have identified simply a lot of problems with their existing API architecture. So what they were able to do, so basically we are going to look into individual problems that they identified. So when we look at the entire UI, which we can see on the left side, we have built. Actually, Facebook has built their UI component in component manner, so everything is separated. But to populate data into those components, they have to request information individually from different services. For example, in this representation, we have 4 network calls going from 4 separate UI components to 4 different services. So the problem with this approach is network only. For individual calls, they have to initiate a TCP connection and do all the security stuff, and they take that data back and do the parsing and serialization, and finally render all those information back in the UI. And another problem is interdependence of requests. Maybe there are scenarios they take the data into the header, and depending on the data available in first request, they will have to go forward with the second and third and so on. So there's a dependence between individual requests, which they have to manage in the front end logic. And then we have managing loading, failure, and success state separate. So when we have so many network requests within the same interface, they have to manage different states for each and individual request. So we have to adapt the UI to represent loading, status, failure, and success individually for the request. And so one of the solutions at the time that people were doing and how they address this kind of a problem is basically writing a special service which is able to aggregate data from all the previous services and expose them to the front end. So according to the information requested in the front end, they will have a special service which will expose all the necessary data for that particular UI. So actually in this case, the backend has to be modified in order to optimize for the request. And also, so whenever they create a front-end page, they have to create a backend special API endpoint where they can fetch the necessary information. And there are scenarios, there are certain APIs which have additional data which are not presented in the UI itself. For an example, in this case, we can see in the front-end UI, we have the ID column and the title column. But if we look at the payload which is received from the backend, we have an additional field which is called expensive field. But in real world scenario, it can be anything which consumes a lot of CPU and memory resources in order to get the final value. So this was a common scenario back then. So they wanted to address these instances as well. So when if you are discussing the payload like this, which might have complicated data logic, and when data is from multiple executable sources which are integrated and deployed, there can be third-party requests that need to be triggered in order to populate the data in the final response. So the problem with this is, even though, for example, if we are not actually showcasing the data, which is if we say talk about each of these, we have to go to AWS Aurora database and also a Lambda function in order to populate that point of data. But if it is actually not utilized in the UI layer, it is actually based on resources that we have to first support. And so what the basic representation that we are trying to do here is, if we have a grid of data, usually these grids of data, for an example, in our Facebook feed API, multiple different types of records are available in the same list. So there can be circles, there can be triangles, and so on. So in their case, it was comments from people, posts from people, which include some included videos, some included photos, and data was so much different. So if they try to create a similar API, they had a lot of problems. So they wanted to support this kind of utilizations of API natively. And so the one more thing they wanted to address is basically about data layer. So I've taken this example from study room context. So if you look at this is basically trying to represent the database structure and the relation. that we do when we do the data modeling part. So we might have a user record, and user can be either a tutor or student, and the particular tutor might have some classes, and a class will have sessions, and session will have reviews and so on. And actually, even though this is the database structure, when it comes to the UI counterpart, this object graph actually matters, because all the data that we store in the database has to be most likely will be represented, but there are scenarios that, example, enrollment record, we don't actually show in the data UI, but that makes sense. But we see a difference between the database schema and how that schema impacts what we call GraphQL schema. So this is actually a better representation that we might need to represent in the UI. Even though in the previous example, we have the enrollment record and meeting configuration and subscription details stored in the database. But at the front-end layer, we only want to showcase certain part of information. But still, the hierarchy and the relationships are maintained. So we should be able to fetch all of this information to the front end. So what they identified is at Facebook when they when they were doing the research for developing this particular technology, is they wanted to have the object graph which is implemented in the backend available in the front end, but without additional overhead of modifying and creating APIs individually. So in this case, we can see a particular API response that might be required. So we can see the student record on the right side, and the personal details are also available in the same response. And the classes that the student is engaged to is also available in the same request. And the class, individual class has its own tutor, and the tutor's personal information is also available in the same request. So basically, the relationship in the database is actually needed in the UI for better representation. So one more thing is, so this is, we are trying to differentiate between the DB schema and the GraphQL of the representation in the UI layer. So for an example, in the database, you might have the title field and the tutor ID in the database stored. But logically, we might want to represent something like empty number of MPCs in the UI level. So those also have to be part of the graph that we are going to talk about, which we need to represent in the front end architecture. So basically, there will be additional information added on top of the DB layer when we want to build the graph that we want to show in the UI. So, and if you remember, in the one of the major problems that Facebook wanted to address is to populate the data into all the views components in the UI, they had to issue multiple data requests. So for an example, if you were to take an example from study room, this is the class overview page. So on the top, we have all the information about the class. And this is actually a single page that is a long page. So we can see the session information is also available in the same page, and the tutor's information also available in the same page, and the rating summary and the reviews are also available in the same page. So if we were to develop populate information for this particular UI with a traditional REST API, unless we create a specific API for this page, we will have to execute multiple requests in order to get all of the information we need. And one of the other things is, even though we are fetching the information from the same record. For an example, if you take the first long image, is basically representing part of the landing page. And if you look at the second class, in the third layer, we have certain information like the number of students and price for individual session. But if the same card is viewed from tutor's perspective, a different part of information becomes available. How many sessions are left on that individual class? So even though we are referring to the same set of data, the fields that we are requesting from the fields that are needed from the backend is actually different. So if we didn't, we need to be able to flexibly request individual fields from the backend. So this actually this person called Nick Shaw came up with the initial idea that they wanted to pair new API technology in order to be able to have this flexibility. So actually, Byron was another engineering lead at Facebook at the time, software engineer, who helped and came up with this idea, who helped me in developing the initial prototype. And Daniel was the head of who was developing the news feed at the time. So these three people came up with this technology called GraphQL back in 2012. Yeah, so the time was 2012. So Nick came up with a prototype. He named it SuperGraph backend. So this is the, actually before making the technology open source. We can see one of the messages from the internal discussion. Actually, the initial it doesn't work. So internally, the initial has referred to this as SuperGraph. And going forward, the idea was originated in February, and they saw a lot of potential in this simple technology. So what they did was, at the time, they were anyway it was doing a revamp on their Facebook iOS application. So they planned on integrating this GraphQL technology in their iOS application. So in the same year, in August, they were able to create a production level GraphQL API for their iOS application on August. And by 2015, the technology was made open source and was open to anybody to use this GraphQL API. So there are a lot of companies right now using GraphQL from Airbnb, Netflix, to Apple, and so many companies. So I just wanted to show you a quote from the GitHub why they are using GraphQL APIs for their public APIs. So a few of the important things that they highlight is being the flexibility for the integrators, as well as the simplicity of having a single API and being able to extract all the information needed in a single API request. So what are the solutions that this particular technology? We will dig into the capabilities of GraphQL in the future slide. Until then, we will be looking at what are the targets or goals that this particular technology is trying to achieve. So they wanted to optimize performance. So as we discussed, there are certain things that we want to show in the UI that might consume a lot of resources in order to populate that part of information. So in case in scenarios that these are not needed, we can actually opt out of processing those information. And so in the previous instances, we saw that developers, the backend engineers needed to create special APIs in certain scenarios to optimize for depending on the front-end engineer's UI. So that is also another improvement that they want to do. And the third one is rapid UI. So imagine an API, usually in SQL, in case we want additional fields, we can add that field to the select query simply. They wanted a similar API that we can do that in the front end with the call itself. And declarative approach available for data output, which means being able to specify all the fields and information from the front end itself, what is actually required from the backend, instead of relying on the backend technology to expose the information requested from the backend. And as we discussed, they wanted to have built-in support for hierarchy and heterogeneous data support, which means being able to expose multiple different types of data. And yeah, we will look into individually all of these points individually. So before going into details on how actual GraphQL queries work, we need to understand a few things we need to understand. So GraphQL is not specific to any database technology. So it can be backed by MongoDB, Postgres, or another call from third-party API, or any different type. It is actually data source agnostic, which means it basically does not rely on the underlying data source. We will discuss how that is implemented and how GraphQL is able to export data as needed. So transport layer agnostic, which means GraphQL can be implemented on top of multiple technologies. So in most of the scenarios, GraphQL is implemented on top of HTTP or WebServer, which are in seven layer of OSI model, but it can be integrated with new technologies like software. The actual data transmission happen in binary, and therefore have very optimized payloads. Yeah. So, and one more thing that I need to highlight is GraphQL is basically a specification, which means a set of rules how data has to be processed and certain queries have to be executed. And different languages, for an example, JavaScript has its own version or implementation of GraphQL specification. So that becomes an implementation. So there are GraphQL implementations for Go, Rust, Java, and many languages. So what GraphQL team came up with initially is the specification on how to process a GraphQL code. And finally, we have 3 points, which are queries, mutations, and subscriptions. So in GraphQL, we divide all the interactions with a certain API into 3 categories. So queries represent obtaining data as we are familiar with, and mutations represent mutating or changing on the data. In the context of REST APIs, we can assume queries like GET request, while mutations represent put, delete, and those requests. And subscriptions represent real-time notifications and data like that. So the user or the client is able to subscribe to certain data streams and have them available real-time in the UI. All right, so let's have a look at one of our GraphQL queries. So previously we discussed there are 3 different types of interactions that we can have with the GraphQL API. So we have to specify what type of interaction that we are going to do. So as the first keyword, we can see query. This can either be mutation or subscription. So in this case, we are going to request for some information from the API. And we are going to specify what kind of information exactly we need. So in this case, we are referring to the same scenario, the data structure that we specified. So there will be a student profile, and inside the student profile, there will be an object called personal details, and the first name and last name will be there. And the output has the same structure that we requested in the code. So this is the basically the magic of GraphQL. So if you remember, one of the points of the goals of GraphQL was to have the declarative approach, which means we are able to specify what we need before making the request, and the backend will adapt according to the request that we send to the API. So basically, what we requested is received on the right side. And in order to send those information to the front end, the API or the backend server need to be aware of what kind of data is available to be sent to the front end. So in order to do that, GraphQL has this thing called type definition. So the developer, the backend engineer has to define what type of information is available in the backend, and the hierarchy will be built according to the specific definitions that we provide. So in this example, we can on the top we can see the query type, which is all the queries originate from this particular root node, which is called query. And under the query, we have the first keyword was query. So first keyword was query. Then the my profile is actually a name that the developer can come up with. So the first field being requested is my student profile. So the definition for that is here. Under query, we have the my student profile, and we have to specify what type of information that will be exposed under that particular field. So we have student. We say the student profile is going to be type, and we have definition for student type. That's it. So student type will have ID, person details, and his own set of classes. And personal details will have type personal details. The type is specified in the right side. It will have first name and last name. Because of these type definitions are defined in the backend, we are able to query the information like this, and the system will make those information available. Yeah. So if you look at this information, there are, for an example, if you look at the student type definition, we have the ID field, and you specify as the type for ID field. But for the person details, we have object type. So in programming also, we are familiar with the concept of primitive types and object types. So that the similar approach is there available in GraphQL as well, where primitive types and also object types are available. So in addition to those types, for an example, by default in most of the implementations, when I say implementation, GraphQL is a specification. So it's up to the developer or the person who develop the library to implement those different types. So by default, in float, string, and boolean, those types are available, and we can create object types by combining already available primitive types. And on top of that, GraphQL has few special types like input, which we will discuss in the future, and this enum and unum unions are also available. So this union play a major role in making heterogeneous data available from APIs, which we will look into in a future slide. Yeah, so when we look at the previous query, how this query will be executed, there's an order. Basically, GraphQL engine will decide, we'll look at the graph of data that we have requested. For an example, it will start from the beginning, which is my student profile, and compare this query against the type definition. So if there are fields that doesn't match the type, that particular query will be invalidated and we will receive the corresponding error message. After the query has been validated, the execution begins, and during the execution, it will traverse through the graph that we have defined. So starting with my student profile, it will try to identify the records that need to be sent as the my student profile. Then once the my student profile is found, it will try to find the personal details that correspond to this particular profile, and so and so. So it will dig into the graph one node at a time. But if there are multiple fields, in this example under personal details, it should be personal name and last name. So those will be executed parallel because we already have the personal details record. You can see how this is executed. So and basically graph traversal is happening, and they are able to extract the information. Yeah. So 3 tiers to GraphQL, which means if we were to develop REST APIs, we are familiar with the 3D architecture, where we have the control layer, which is basically representing the presentation. So if it is HTTP request, this is where we extract the query parameters and path variables according to the UI. But in the GraphQL context, we call this as a resolver. So resolver is really different to a regular control endpoint, which we will discuss in detail. And the resolvers are responsible to talk to the service layer, which is actually service layer and repository layer. There is no change. That is where we actually write the business logic related to the related particular field in the domain. And database layer is similar as in other contexts. So only difference is the controller layer will be replaced by this thing called resolver. So there are certain differences which we will discuss in a future slide. Yeah. So this is the structure of a resolver. For an example, in a REST API, we should usually extract information from query parameters or path variables or the body of the request. But in GraphQL context, the resolver is a little bit different. It always gets information, 4 parameters in an individual resolver. In this case, source, archive, context, and input. So source basically represents the parent. So if we refer to the previous same context, if we are executing the resolver for personal details, the source will be the parent of that particular item, which means my student profile. So and there will be a resolver for each and every node in the type definition. So we have to tell the API how to resolve for each and every node. So for an example, as we discussed, if we are going to resolve for personal details, it is under my student profile. So the source is going to be my student profile. And we are able to provide some arguments, which we will see in the next slide. Context is basically something common throughout the entire list. As we discussed, during the execution, every node is traversed as in a graph, and one particular response is here according to the response from all the resolvers in the graph. So the context is a particular object that is shared between all the resolvers. So if the API was to solve or execute the resolver for my student profile or personal details or first name, the context will be the same. So we are able to input data into the context and take data out of the context. So we will be able to sync with rest of the traversal of the graph. Actually, we will have some examples in the future. And in the info will have data related to the GraphQL graph itself. For an example, at which level we are, I'm sorry, for example, there will be a resolver for first name, which is under person details, which is under my student. So that graph details will be basically metadata of the graph will be included inside the info variable. Which is basically regarding how we can share information between multiple resolvers. So the context is available between the individual requests for all the resolvers. But as in, if we compare this to the approach in RESTful APIs, individual request is handled under single controller endpoint. So it doesn't have to execute multiple endpoints in order to access data. So, but in this case, what we are doing is, if you look at the last 3 lines, you can see user information is injected into the context of the graph. So within any resolver, for an example, when we try to resolve for personal details or when we try to resolve for my student profile, the request user information will be available throughout all the resolvers. And we can see data loader, something called data loader is also available in the context. We will see in a future slide where that comes handy and useful. So we can actually inject any kind of information into the context, and the context will be shared across all the different resolvers available in the schema. And during when I introduced to resolvers, the third parameter was basically arguments. The first was the source, which represents the parent object, and then we have the arguments of it. So this is how we can introduce arguments into our field. So basically, this is the same query that we had earlier, but the personal details part has been replaced with classes, right? Because in RESTful APIs, we introduce arguments through maybe query parameters or post body, request body. So in GraphQL, we are able to inject all the variables or arguments inside the field at the field level. For an example, we can introduce arguments at my student profile. In this case, what we have done is when we request for classes, we provide this additional argument called type. So we are able to query for on-demand classes, we are able to query for live classes or one-on-one classes, or so and so. So whatever the information we provide as arguments at this layer will be available to the resolver function during the within the implementation. So all the arguments are accessible, and we can export the information at individual level according to the arguments applied during the request. And then we have this thing called variable. So here the difference is in the previous slide, under the classes field, we have type as on demand. So it is static, which means it doesn't change. The query is static. But in this case, we are able to introduce variables into the query in GraphQL, which is called a class type, and we have to define the type like as in type. So basically in GraphQL, the type is defined in front of the variable with the call. And that particular variable, which is class type, can be used in the classes field as an argument. So we can have as many variables as possible, and we can utilize those variables for many different purposes. In this case, we are using it as an argument for a particular field. In the future slide, you will see how we can make use of variables in the context of directives. Yeah. So building payloads with aliases. So imagine a scenario we need to, so I think you have the context of classes, tutors, and students, right? There are classes, there are tutors, those tutors have classes, and the classes will have sessions and so on. So imagine we want to fetch a set of classes for a particular student, but we need live classes along with all the on-demand classes. In a traditional API, we will have to execute a REST query with multiple different arguments, right? But the advantage of GraphQL is you can specify live classes as a special field and call the same classes resolver. So if you can see the in front of live classes, we are calling the same classes resolver with live arguments. And in the on-demand classes, we are calling the same resolver but with a different argument. And we request only the title field from both of the different types of classes. And we can see in the output we can see in the output under live classes array, we can see only the title as well as in on-demand class. But we can name the field under which we receive information as we want. So the live classes and on-demand classes are never defined in the type definition. What we have in type definition is basically the classes resolver with the type of array of classes. But we use the same resolver to build the customized payload for our particular purpose. So in this case, it is basically having a single request which has live classes data as well as on-demand classes data. Code we use with fragment. So the advantage that we were expecting from GraphQL is being able to specify what we need. But this can be a trouble in certain instances. For an example, imagine we were to extract live classes and on-demand classes as in the previous example. So in this case, we are only requesting title from all different classes. Imagine we had ID, titles, the tutor of the class, and tutor's first name, last name, and so on and so. In a production scenario, there will be a lot of fields that we will have to repeat in both live classes and on-demand class instances. So that is a lot of code repetition, which as software engineers, we need to try to prevent from writing. So GraphQL has a solution for this problem, which is called fragments. So we can give a name for a certain set of fields that we want. So in this case, we create a fragment called class card, which is basically to populate data into a class card, which we saw in the previous screenshot. We need the ID, title, tutor, personal detail, and first name and last name. So these set of fields are needed again and again. So maybe in my classes, maybe in the browse view, maybe in live classes, maybe in on-demand classes as well. So without repeating those fields, we can create this fragment and use the fragments as in the query below. So in the query name fragment, we are going to specify all the individual fields at that level. Instead, we specify the name of the fragment so we can extract all the information. And in the payload, we can see both for live classes and on-demand classes, we can see the first name and last name, all those fields are received from the API. Yeah, then we have another feature in GraphQL called directives, where we are able to customize the query itself. For an example, we might have a big query where we extract the information from multiple services, a lot of fields, but we want part of the query to be executed only if the particular user is logged into the system. So what we can do is, in the first line, what we have is a variable, which we discussed as a feature of GraphQL initially, with the type for Boolean and a default value of 4. But now in front of my student profile field, we have this @sign which includes an statement. So basically, this particular resolver, the resolver for my student profile will be executed only the log field variable is set to true. So we are able to customize which part of the resolvers are executed using the variables that we define in the query. So all of this is happening in the front end. The definition of the query is happening in the front end, and the backend is able to understand the query and execute only the part of the code that is required to process this part of information. And one of the problems that Facebook wanted to address with GraphQL is basically ability to represent heterogeneous data or multiple types of data in a single list. So how GraphQL addresses this problem is we can define fields like this. So previously we had my profile query. Now we have a query named heterogeneous, and under that we have a field named browse. Under browse, we can specify we need a title field from class type and first name field from tutor type. So in the single field, but we can define the nested field for multiple types in the same nested API. So here in the output, in the payload, we can see for class instances, we can see titles like learn GraphQL, learn gRPC, learn Kubernetes. But in tutor instances, we can see the personal details, first name, and me and Joe. So, so a single particular API will be able to export all the information at once as we need. And there's another thing called data fields in GraphQL, which is used to expose information about the GraphQL API itself. So for an example, when we request for browse, we showcase the ability to expose multiple different types of data. In that case, tutors and classes from the same resolver. But if we wanted to differentiate between two different types in the UI, basically to render a different component logically, depending on the type, we would like to know what type of record that we are receiving. So for that, we can specify this underscore type name. All those meta fields start with a double underscore name, and there it will represent actually what type of object that we are receiving. So in the output payload, we can see in the first learn GraphQL field, we have the class type. So this name comes from the type definitions that we discussed earlier. So according to the type definition, the API is able to expose this meta information about the GraphQL API. And we will look into few other meta fields. Yeah. So schema is another meta field that is available from GraphQL, which is going to be useful to understand what the GraphQL API is about. In this case, introspection, which means getting to know what the API is capable of. So we can query this schema meta field to get information what type of queries are available in the API. So here we can see under schema, we have the query type, and we request for fields in the of query type, and we are requesting name and the type kind of individual query types. So if you remember, in the query type, which we discussed earlier, we had classes, browse, and my student profile. So here in the output, we can see under field, the class field is also available, which has the type object, and the browse field is available, which has the type list, and my student profile, which is an object. So the type definition is decided by the backend developer. But this information is available to the front-end developer to understand what the API is able to export. So they will be able to understand the structure and what kind of information is exposed. And another example of introspection and another meta field, previously we used the schema to get information about the root level schema. But in this case, we can specify a specific type definition. So we have the argument name and student. So we are going to get information about the student type definition. So this doesn't actually relate to the data that is actually being exposed by the API, but this is all about the API itself. So here we can see from this student, we can in the payload, the name is student and a description and the fields available under that particular student field. So ID, person details, and classes and description. So this is actually a specific example using Node.js example. So this will be different according to the language that we are going to work with. A Java example will be different, and a Rust example will be different also. But as we discussed in the type definition phase, the backend developer needs to specify what type of data is available from the GraphQL API. During that definition, GraphQL support the description. So at each and every field level, each and every argument level, the developer can specify a description about what kind of data that particular field is exposed. And so the advantage of this thing is the API itself is able to expose all the fields and structure about. So there are tools developed like GraphQL and GraphQL Playground. So this GraphQL Playground tool, which I have a screenshot, is developed by Prisma. What it is capable of doing is it is going to query the GraphQL APIs using those meta fields and identify the internal structure of the GraphQL solution. And then it is able to create a documentation automatically because all the information needed to generate the documentation is available within the API. So in this case, at the query level, we have the class browse my student profile. So we can select what we need information about. If I select my student profile, we can see the type details, student who is enrolled in the class and consume content available in the platform. So this is a description that is defined by the developer during the type definition. And we can see what is available under my student profile and so and so. This is nicely documented, and we can see the structure of the API from the UI itself, and everything is auto-generated. And so far, we were discussing about queries where we fetch or request for information from the GraphQL API. But in this case, we are going to talk about a specific scenario of reading data or submitting data to the API itself. So what we can do is the structure is similar. As we discussed, the first keyword starts with mutation. Previously, it was a query. Now we have mutation, and we can give any name we want to name the mutation. In this instance, we have a class, and then the actual name of the mutation that we have defined. So in this case, it's going to be class, and it has an argument. This is the same concept that we discussed in a previous slide. And under that argument, we have another object. So on the object, we can do all the fields that we need about the class. And as a response, the final part is about the response received from the mutation. So in this case, when the class is created, we are only requesting for the title of the class. So, and on the left, right hand side, we have the corresponding resolver function. So under argument, we will be receiving the title. As we can see, on the left side, class has the class argument, and we can access the argument that is supplied, provided in the actual code base on the right side. You can see in the title here, args.class.title is taken from the arguments variable. So actually, in this case, this is actually pushing the new record to an array. But in a production scenario, this is going to be basically submitting data, first doing the validation and submitting all the data into the database. All right. So we looked at all the advantages that we can have when we implement the GraphQL API. But there are certain problems that comes along with all of these advantages. For example, we discussed how individual node in the graph will have its own resolver. So if we refer to the same graph, let's look at, I have to repeat this part again and again to explain this. So my student profile, classes, student, and class and tutor. So imagine my student profile represents the individual student. let's say I am logged in as the student. So my student profile is my profile, and we are requesting classes. So there's a resolver for classes field. And so it will be able to send a database request. So we have this request which is there in the right side. In the payload from the classes, we can send array request to the database. So when we resolve for the classes, we can send a single request saying I need the class record that I have enrolled. So that is an individual request. And we take that information, and then in the query, we have the tutor field specified for each and every class. So on the class field, there are, let's say, 100 classes, and 100 classes will have their individual tutor field. So there is a corresponding resolver which will be executed 100 times. Which will be executed 100 times. So if we were to do this, there will be another 100 database calls to resolve the corresponding tutor record. So this is called N+1 problem, where N1 represents the initial party database call, and N represents the individual database request sent to resolve the tutor that corresponds to the individual class. So this is actually not a very optimized scenario. This is going to put a lot of load on the database, and the basically response time is going to have a major impact. So how do we solve this problem? In the context of GraphQL, we have this thing called data loader. So what we just is basically we have to send all the data requests through this special object or implementation called data loader. So when we send in this example, when the GraphQL resolvers are trying to resolve the tutor that correspond to an individual task, it doesn't directly go to the database. Instead, it goes to an intermediary called tutors loader. So what tutors loader does is it won't resolve or ask the database right away for that particular record. It will wait for rest of the array to be resolved. For an example, it will collect all the information, actually all the requests from all the results. So we can see for the first class, the tutor ID is 1. So data loader receives a request to resolve tutor ID 1. The second class is also conducted by student tutor, and therefore the data loader receives a request with tutor ID 1. But the third class is actually from a separate different tutor, and therefore it receives a request ID 2. So now previously all of these requests landed on the database server, but in this case, data loader is the process within the same application. And it will receive this request asking for tutor ID 1 and tutor ID 2. So therefore, the number of requests received by the database is reduced. And also, there are few advantages. So this part of the data loader is called batching. So all the individual requests are batched into a single request and sent to the database. And there is another feature called caching from data loader. So for example, if we were to fetch the same tutor record in separate part of the query, let's assume we are requesting from the same tutor information in a separate part of query. In that case also, if it is already received from tutor ID 1 and it is available in the tutors loader, the request will not land in the database, but instead it will be obtained from the data loader itself. So using actually implementing data loaders is kind of a must when we develop production level GraphQL APIs. And when we develop APIs, one of the basic things is we initially focus about the success scenario, but we need to be able to focus about scenario. Those energies completely different. Because GraphQL has to execute information for a single query. So there are those errors can occur at multiple levels. It can be a first-time resolution. So what GraphQL does is when the particular resolution is successful, it will send that data. For an example, In this case, we have the my student profile, which is a success. So if you look at the right hand side payload, we can see the my student profile is there. Under that, we have the personal details and first name and last name. So all the information is available. But if you look at the classes, in the query, we have requested the title field of the classes field. But in the response under data section, you can see classes have a title of none because there is an error on retrieving the data related to the title. So the GraphQL payload actually separates the data from the error part of errors and data separately. So we can see the error section on top and it has all the error information. So in this case, as we have three classes that needs to be sent to the front end, the GraphQL API has tried to resolve for individual titles lists for individual class. And it has faced three different failures. So all the information about all the errors are available in the error section. So we can see in the first error, under the path, we can see the path my student profile, classes, the zero index, and the title. So when it was trying to find the title for the zero class, it faced an issue. So we can see the message error retrieved in the class title. So throughout the graph, when the GraphQL engine travels to the graph, errors can happen at multiple levels, and all those errors will be collected and will be presented to the front end in a similar manner. So if so there can be partial success as well as therefore partial failure. Yeah. So with GraphQL, there's a lot of flexibility for front-end developers. They can query a lot of information in a single request, they can customize the structure of the data that they are receiving from the backend. But there's a big security risk along with this flexibility. For an example, the front end is able to submit a deep query, which means we have a great example here. So we have a query named dip and the same scenario. So my student profile, we have the classes and we have the tutor of individual class. And the tutor will have his or her own classes. And those classes will again have a tutor. So there's a cyclic dependency. And we can send a query asking for all of these relations. Tutor class, tutor class, tutor class, and so on and so. So what happens is the corresponding resolvers will be executed in the backend, and therefore it will try to find details for all the queries that the front-end has specified. So this is kind of a DOS attack because this will consume a lot of server resources for trying to find all the information according to the query. So this kind of attack we call depth-based. So so we will see how we can prevent this kind of attacks. And another way is, for an example, there can be different complexities associated with resolving individual fields. For an example, my student will have profile might be a single request to database, which is very simple and therefore consumes a lot of small amount of resources. But there can be a total classes field under a tutor which needs to aggregate a lot of information in order to get the final output we need. So we can actually have a number associated with each and every field called complexity, right? So the users are able to request the backend with queries at different complexity levels, therefore consuming more resources than expected. So let's look at solutions. The first solution is timeout. So timeout is basically whenever a particular request takes too much time for processing than a certain threshold, it will stop responding to that particular request. But the problem with that is because the query is already received and the service is going to process that request. So the damage is already done, but the client will not receive the response. And the second approach is we can implement certain security measures depending on the depth of the query. For an example, we discussed in the depth query, in the example, we can see a depth of CERN, which means lot of nested fields So we can keep adding or incrementing the field depth value according to how many unexpected structures that we have to go through to reach them. So the final tutor field in the first example has a depth level of 7. So if this keeps going for thousands of records, it's going to be a dose attack. So what we can do is, before executing the GraphQL query, we can go through the query and identify the maximum depth. In this case, the maximum depth is 7. So we can limit the API from not responding to queries which have a depth more than 3, let's say. So this is actually, it's up to the backend developer to decide how much of a depth that the API is going to allow for the query. So we can limit the request and secure our API with specifying the depth level. And we can implement the same kind of if a particular user is requesting for information which are too complex in a single request, we can stop that query from being executed by specifying the complexity parameter to individual field level. Okay, and so in the depth-based strategy, one of the advantages is the query is not executed during the. If you remember in the previous slide, we discussed the multiple stages of validation and execution. So during the validation process, we can identify what is the maximum depth requested within a single query. And therefore, the execution is not happening, so there is no damage or no additional resources consumed from the server side. And finally, we have query analysis system. In the complexity layer, one of the problems the backend developers will face is coming up with the threshold value. As we discussed, we have to come up with a value. After a certain amount, we are going to restrict the clients from making requests. So that actually depends on different domains and it could be complex. So that is a challenge that the backend developers have to face if they are implementing different according to complexity metrics. And finally, we have total. So totaling, which is I will have a detailed example of totaling in a future slide. So totaling can be implemented with the complexity that we discussed as well as utilize server time. We will go through an example in the next slide. Yeah. So in computer science, we have this algorithm called leaky bucket algorithm. So basically, what it does is imagine a bucket which has a certain amount of capacity. So in the graph, we have a representation of how this algorithm will be executed. So on the x-axis, we have time. So I'm just going to explain the leaky bucket algorithm, and then we will discuss how we can implement security or defend our GraphQL API using this particular algorithm. So we have a bucket with a capacity of 5. So in the graph, you can see the red line, which represents the limit of the bucket, which is at the level of 5. So the bucket's capacity is constant and it is not changing. And then we keep receiving different requests to our API. Basically, that represents the incoming water droplets in the left side. So you can see a lot of droplets are received by the bucket, and we can see the leaf as well. So for a certain, in our example in the graph, we represent the leaf with yellow line, which means every second one unit will be lost from the bucket. So this unit is up to us to decide. That is why we discuss the query complexity. So we can take query complexity as the unit, or otherwise we can take serve execution time as the unit. For an example, if a particular query takes, let's say, 200 milliseconds to execute, that is a request with a 200 millisecond drop of water. So that will be accumulated in the bucket. So let's look at the example. The request is represented by the blue line. In the first second we are receiving two units, let's say 2 units of complexity. And there's a 1 unit of leakage, and the green line represents how much is accumulated or collected in the bucket. So because we received the first request, we received the request of complexity 2, and we have 2 units in the bucket. And in the next second, 1 unit is going to be leaked because that is the nature of the bucket. So we had 2 units, now it's going to be 1. But in the second, we are going to receive another request with complexity of 3. So we had 2, 1 got leaked, and 3, we receive another request of 3 complexity. Now altogether we have 4 of complexity in our bucket, and so on. So the API will keep receiving many requests with different complexities, and our bucket will get filled if we receive a lot of requests within a limited period of time. Yeah, that's basically it. So we can decide on the limit of the bucket, so how much our API or servers are capable of handling, and also how much leakage we should allow for the system to handle. So at you can see at the 6th second, the leak is concerned at level 1, and previously at the 5th second, we have 4 units of request or complexity in the bucket, and in the 6th second, we receive a request of 3 complexity. So 4 units were there, and 1 got leaked in the next second, and 3 units got added, and therefore the bucket goes up to the level of 6 units of complexity. Therefore, now it is beyond the limit, which means we are going to restrict that particular client from making requests to our API. So this is one of the ways that we can implement and defend against such attacks. All right. So we discussed major features of GraphQL, being able to integrate many data into the same request, and the flexibility available from the tool itself to have different structures. So now we are going to look at different ecosystems around the GraphQL API. So one of the packages or systems that are available is called Apollo. So if you are doing React-based development, this Apollo package has client and a server, so it's really convenient for you to start developing GraphQL API and also handle requests. So we won't be going into detail on how the specific details according to the framework. So, but Apollo is a nice and definitely great implementation of GraphQL, which you guys need to look at if you are going ahead with GraphQL implementation. And Nest.js also has great support for GraphQL APIs, amazing documentation, and being able to introduce custom decorators, custom scalar type, and so on. So it has amazing documentation and implementation, which helps developing APIs faster. And AppSync is a solution from AWS. It's specific to AWS, where they provide features on integrating GraphQL APIs directly to all of their data sources. For an example, DynamoDB behind the scenes, and expose the data in the DynamoDB with a GraphQL query. So, and also this doesn't have to be a single data source. So in case of AppSync, you are able to integrate maybe DynamoDB with another Lambda query. So multiple sources can be connected to the same AppSync instance. So you can expose all the information from one single GraphQL API. And we have this technology called Hasura. It's something similar to AppSync, but it's not proprietary technology like in AWS. So there is another great solution where you can integrate many different data sources into a single GraphQL API. This is actually, I took this image from AppSync official website from AWS. So they represent how we can create a single GraphQL API, which is represented with AWS AppSync part of the image. And we will be the mobile lab, real-time dashboards, all will be talking to the same GraphQL API, where GraphQL or AppSync instance is able to retrieve data from all different types of sources like DynamoDB, Aurora, OpenSearch, or Lambda. So there's a lot of flexibility in selecting the data sources, but we have a common way of interacting with all different those data sources. So this is going to be a huge advantage when we develop API. And Hasura is another system that is available for developing GraphQL API. So on the left hand side, you can see on the bottom we have an app which is going to talk to this service called Hasura through a GraphQL query. And what Hasura is going to do is understand that GraphQL query, and it will be able to translate that GraphQL query into SQL, which will be received by different databases. So so Hasura supports a lot of different types of databases like Postgres, Microsoft Windows SQL, Google BigQuery. All the major database technologies are supported by Hasura. So you can turn all of these different data sources into GraphQL API. And if your client, mobile app, dashboard, or front-end website is compatible or able to send GraphQL query, you can extract data from any different kind of databases that we discussed by using something like Hasura. And finally, we want to discuss a little bit about support for this technology. So I had a look into the NPM live packages that we have, basically JavaScript implementations of GraphQL engine. And the percentage of cases that we have about 9 million, almost close to 10 million weekly downloads for GraphQL, and which is actually frequently updated. And so there's a lot of people using the GraphQL packages. So yeah, it's really good if you have a good use case for it. And the data loader package, which we discussed earlier, also has about 4 million weekly downloads. So it's widely used by the industry. And if you might be coming from different ecosystems from C#, Java, or Rust. So you can see GraphQL engine is implemented in so many different languages. So this is actually taken from official GraphQL documentation. So they have support for Go, PHP, Rust, Scala, or R. So most of these languages are able to build on top of GraphQL as well as query from systems or in GraphQL APIs. And finally, I wanted to give some ideas about what other companies are doing with GraphQL technology. So I have included some links. I'll share this particular slide so you can have a look into these documents. So the first one is about how Twitter used GraphQL to optimize their API and how they could take advantage of this technology. And Airbnb is more than 10 times faster because of the flexibility of GraphQL, and they are using GraphQL internally. And there are so many other examples which I haven't included in this particular slide. PayPal is using GraphQL, and Medium themselves have GraphQL API, and these are one of the highlights that I wanted to include. So Airbnb, Twitter, and Netflix. So Netflix actually have a specific scenario called GraphQL Federation, where GraphQL API actually acts as an API gateway. So it's pretty interesting stuff. So if you're planning to go ahead with GraphQL, please have a look into Schema Federation and how these companies are also leveraging this technology to make their systems faster and flexible. Yeah. So when you use GraphQL, there are instances, as you can see, as you might have, as you discussed, code into the query. So we can optimize the code being executed. So there are instances where the data is received from multiple databases, multiple data sources. So that will leverage a lot of latency. So we can make a lot of optimizations using GraphQL because we will talk to only the data sources actually required to get the information from. And there can be instances where network usage is very critical. That's why Facebook was one of the reasons why Facebook considered this approach. So when they develop their mobile application, they can request all the information needed within a single request. And rapid changes. So as in the core examples, we can keep adding and removing field into the query, and we don't have to make any changes in the backend data yet. All the data we need is once in the graph is available for anyone to query. But we can implement authorization and all that measures. But as long as we have defined the logic on how to extract those information in the backend, we can take that information to the front end without making any changes in the backend. So type of pair of clients. This is very important. So there can be scenarios where there's a mobile app, a web app, and maybe a desktop application where they want information about the same data or entities, but with different levels. Mobile app will request for few simple fields from a particular data set, while a desktop application might request detailed information about a certain entity. So in using GraphQL, we can optimize for both scenarios without writing special code because GraphQL is inherently able to handle the query flexibly. And another case is real-time updates. So GraphQL has, which we didn't discuss so far, is one of the things that we discussed. Queries and mutations. There's another thing called subscriptions, which I explained earlier, where we are able to subscribe for certain events. So if we were to implement GraphQL on top of WebSocket technology, we can have real-time updates from servers using GraphQL itself. Yeah. And when not to use GraphQL. If the API is extremely simple, if we can expose a REST API which has simple endpoint, implementing GraphQL takes a lot of effort. We need to have GraphQL schema definition, type definition, all that stuff which is not needed in a traditional API. On top of the schema which is needed anyway. So if it is an extremely simple API, we don't need to opt in for GraphQL where we have certain set of overheads during the implementation. Schema setup and developer seats. So when we implement GraphQL API, that initial part of configuration where we define the type definition as well as the developers need to be aware about data loader and special scenarios on how to handle complex queries. So if the particular team of engineers are not so familiar with the GraphQL, it could be a little bit of risk opting into GraphQL. And if you didn't implement it properly, it could be a very problem where latency and data fetching can be problematic. And complicated caching. In traditional APIs, we have certain caching settings implemented in the browser itself. But caching GraphQL queries is very complicated. Not very complicated. There are already solutions, but they are complicated relative to the traditional caching methods available for normal REST requests. For an example, we are sending all the GraphQL queries to the same endpoint with a post request. So the same endpoint which you expose send us different type of information according to the query. So caching all of these different queries is different in GraphQL. So there are actual caching implementations available from Apollo, which I mentioned earlier. Apollo has different technologies. So especially Apollo has server-side and client-side caching mechanisms from their side, which we are not going to discuss in this presentation, but those are available. And cannot implement URL-based authorization. For an example, there are systems which were initially designed to make authorization available through the URL. But the problem with GraphQL is we are communicating always with a single URL, with a post request. Most likely post request, we can customize that, but individual resources are not obtained from different URLs. So if you have an authorization solution which depends on the path or the URLs, you are not going to be able to implement that. No first class file upload support. As we can see, GraphQL always deals with the query string or mutation string or a subscription. So GraphQL doesn't provide first class support for update. And if you have complex database queries as well, where with a lot of joins and so on, the GraphQL might not be a solution because the data loader handles certain cases where you can optimize for database load. And but for those instances also, especially in Java, GraphQL implementation has a feature called look ahead, where you can implement joins as well. Yeah, so there are things that I didn't talk about in the presentation. So I wanted to mention those things also. So if you guys are interested in GraphQL, you can keep doing your research with this fact. So we will look into examples of subscription. We will look into how Apollo makes implementing GraphQL really convenient for React or different frameworks. So, and the caching related to Apollo, and how we can implement GraphQL APIs in React, and schema federation, where Netflix comes in. They have great implementation of schema federation. So, and GraphQL as API gateway. So these things are also concepts that are being developed and currently being utilized in certain companies for their solutions. All right. So thank you guys. I hope this session was useful and you learned something new about GraphQL. And that's it from my side. All right. Thank you.